In this tutorial, we are going to talk about limits, continuity of limits, differentiation, which comprises of product law, chain law, and quotient law. Then we'll also talk about first principle, and also we'll go further and also talk about how to find the equation of the tangent. Okay, so let's begin our discussion with introduction to limits. So the first question which I have here is under limits, which is saying in each case below, evaluate limit if it exists. So the first question is limit as x is approaching 2 of x to the power 3 minus 4x plus 1. So for this type of limit, if you plug in the 2 directly, the function is going to be defined. Okay, so when you want to plug in the values, you stop introducing limits. So in this case, for part A, I'll just say is equal to, then where there is x, let's put 3, but it is raised to the power 3, then 4 raised to the power times 2 plus 1. I'll end up having 8 minus 8 plus 1. Then I'll conclude that my answer is 1. That is as exactly as part B. Okay, part B, I'll do the same. So I'll just say equal to, because I want to plug in the value direct, 1 minus 8 times 3. So it's negative 3. So negative and negative is going to be positive, and I'll end up having 1 plus 24, which is going to be the root of 25. The root of 25 is 5. As simple as that. Now let us go ahead and do part C. So part C, guys, here we can clearly see that what we are going to have, we have got limit as x is approaching 2 of x to the power 3 minus 8 divided by x minus 2. Okay, now the numerator here, I can write this to be the same as 2 to the power 3, because 2 to the power 3 is 8. Then it will go back to that. Okay, so there is a formula which I want you guys to follow immediately when you have been given x to the power 3, then with anything to the power 3. So if you have got a raised to the power 3 minus b raised to the power 3, the formula which we use is, we use a minus b in the brackets, then a plus ab plus b, like that. But if I have a different one, let's say we have a to the power 3 plus b to the power 3, then it's going to change. It's a plus b, then times again a, then here there will be minus ab plus b, like that. So I want you guys to understand and know these simple formulas. Okay, so in a case where we have this guy, so I'm going to use this one to find what x to the power 3 minus 2 to the power 3 is. So I'll say x to the power 3 minus 2 to the power 3, following this formula, is going to be x minus 2, then x, okay, plus ab is x times 2, which is 2x, plus b is 2. Okay, it's the one which I'm going to replace it with the numerator here. So we'll go ahead and say limit as x is approaching 2. On top now I'll put this, I divide this by x minus 2. Now I'm doing this because I forgot to tell you the reason why I'm doing this. The reason why I'm doing this is if I'm to plug in the values here, 2 raised to the power 3 minus 8 divided by 2 minus 2, I'll end up getting 0 over 0. 0 over 0 is undefined. So we don't want this function, this limit, to be undefined. We want this limit to exist. Okay? So I'm trying to find a way on how I'm going to make this function to be defined, or this limit to be defined. So that's the reason why I'm coming up with all these complicated formulas for me to make this limit to be defined. Okay, so if I plug in direct, I'll end up having undefined, which is 0 over 0. So here now I can cancel this guy, I can cancel that, meaning that I will no longer have 0 on the denominator. So I'll have x plus 2x plus 2. Now when you reach at this point, when you want to plug, have you seen guys, I've been just following, I've brought limit here, here limit, as well as limit there. So immediately when you want to plug in the value of 2, that's when you stop introducing limit. So it will be equal to, so I'll put 2 plus 2 times 2 plus 2. So that is going to be 4. 4 plus 2, 6. Then I'll end up having 8 as my answer. Okay. So it's something that is not complicated. So what I'm going to do, I'm not going to get rid of this formula because I think I'll need it for the second question or the next question, which is part D. Okay. So it's basically the same thing on the denominator. We can clearly see that we have limit as x is approaching 3 of x minus 3. Then on the denominator we have x to the power 3 minus 27. So the denominator can be we can write that one to be like x minus 3, x to the power 3 minus 3 raised to the power 3, meaning it's going to be the same. X to the power 3 minus 3 to the power 3 is going to be x minus 3, then 3 plus, I'm following that one because there is minus, 3x plus 3. So this is supposed to be x, the first part, x plus 3x plus 3, like that. Now what I'm going to do is I'll say x minus 3, then x minus 3, x plus 3, x plus 3. X minus 3 and x minus 3 can go. If I plug in direct as I said it already, it's going to be 0 over 0, which is going to be undefined. Now from there, I'll say it's going to be limit as x is approaching 3. On top I've remained with 1, x plus 3, x plus 3. I want to plug in the value, it's not going to be undefined, so I'll say equal to 1, 3 plus 3 times 3 plus 3. So it will be 1 divided by, this is 9, 9 plus 6, 15. Or you say 9 plus that, 12, 13, 14, 15. So we end up having that to be my answer, 1 over 15. Okay, so that is this for part D. Now we have jumped to another part of limits, which is part E. Let's see. So part E now, which is saying limit as x is approaching 1 of x minus 1. So I want to show you something, guys. X minus 1 divided by 2 the root of 5 minus x. Let's try to plug in the value direct. So it's going to be 1 minus 1, then 2 minus, here is going to be 5 minus 1, which is going to be 0 over, here is going to be the square root of 4, 2 minus, so the square root of 4 is 2, 2 minus 2 is 0, so it's undefined. Now this one even if I rationalize the denominator, I'll still end up having 0 over 0. So the only problem which is here, it is approaching to a number and not infinity or 0. So I'm going to use what we call L'Hospital's rule. So this rule states that if you plug in the values and you end up, that is if it's not approaching to 0, okay, and infinity. So what you normally do is you differentiate the function. You take the first derivative, then you plug in the value. So for example, I'm going first to take the derivative of this limit. So what is the derivative of x minus 1? Is 1. The derivative of 2, is 0. So that one I'm going to leave it. Meaning, I want now to differentiate this. Negative 5 minus x, which is the same as negative 5 minus x raised to the power half. Differentiating this, I'll use chain rule. You drop the power, so it will be that. This keep constant, 5 minus x. Then this reduces by 1, which is going to be negative half, times the derivative of what is inside, which is negative 1. The derivative of inside is that. What I mean is this. F of x is equal to, if you have got u raised to the power n, so f prime of x, you drop the power, keep this constant, the power reduces by 1 times the derivative of what is inside, which is the derivative of u. That's what I've done here actually. So negative and negative will give me positive. I'll end up having this. Now I have to shift this guy to go on top for me to remove negative here. Okay, so it's going to be 1 over 2 5 minus x raised to the power half, of which is the same as it is 1 over 2 times the square root of 5 minus x, like that. Now this is basically the same as 1 divided by 1 2 root 5 minus x, which is 1 times 2 root 5 minus x, like that, over 1. Meaning now I've got limit as x is approaching 1 of 2 root 5 minus x. And then at this point I know that when I plug in the value of x, it's not going to give me undefined. So I'll say 2, then 5 minus 1. So it's going to be 2. 5 minus 1 is the square root of 4. The square root of 4 is 2. 2 times 2, 4. So I'll end up having 4 as my answer. Okay. I think that's the same concept which I'm going to use for which part? For f. But f is the same concept. So let's do this. Try to solve this one using the same principle. You first differentiate. Anyway, let me just solve for you. So if I plug in direct, I'll end up having 3, that is going to be 0 over 0. So I need just to differentiate it. So limit as x is approaching 1, the derivative of what is on the derivative of the numerator, which is x minus 1, is just 1, divided by the derivative of negative 3 is positive. Oh, it's 0, sorry, it's a constant. So now I'm trying to differentiate what x minus plus 1 is, which can be written as x plus 1 raised to the power half. Like I said, you drop the power, keep this constant, the power reduces by 1, so half minus 1 is negative half, times the derivative of what is inside, which is 1. To remove negative as the power, so 1 will go on top, so 1 divided by 2 x plus 1 raised to the power half, meaning 1 over 2 the square root of x plus 1. That's what I have now here. 1 over 2 the root of x plus 1, which is the same as the one I had for question E, where I'm going to say it is limit as x approaches 1, so it is 1 divided by 1, like that, of which if I do the reciprocal here, I'll end up having 2 the root of x plus 1. So now I can plug in. Okay, I'll end up having 1 plus 1, which is 2 root 2 as my final answer. Okay, so now let's go ahead and do part G. Part G, we are talking about limit as x approaches infinity. Now, I'm going to give you a scenario or a very simple um, concept under this. When we're talking about limit as x approaches infinity, what do we really talk about? We know that this is 0. As x is getting closer to 0, what is the value of y? Okay, now in this case we're talking about positive infinity. So as you are getting closer, this is x, as you are getting closer to 0, what is the, as you are getting closer to positive infinity, as x gets closer to positive infinity, what is the value of y? Because that's the same as y is equal to limit as x approaches infinity of 1 over x. Okay, so when we're talking about positive infinity, we are going this side. So as we are getting closer to positive infinity from that side, what is the value of x, of y? So as we are getting from here, as we are getting closer to positive infinity, the value of y gets smaller, which is going to be 0. And the best example I can give you is, let's get a very big number, 1 over, let's say the number which we are going to get is maybe 1,000. So 1 divided by 1,000, because infinity is a very big number, is going to be 0.001. What if I say 1 over 10,000? So it's going to be 0.0001. So as you can see, as you are approaching infinity, the value of y gets closer to 0. So what I want to remind you is that 1 over x, as long as x is approaching infinity, the answer is 0. So for this equation, for this limit, the answer is 0. Okay, let's go to part H. Now for part H, I want you to understand one thing. Here is a different thing. I cannot use hospital's rule, the one I use for E and F. Okay, because if I differentiate, then I'm not going to have x. Therefore, the only thing which I'm going to do is I'm going to use, I have to do both sides, because if I plug in 2 direct, I'm going to get 0 over 0. I'm going to get 4 over 0, which is undefined. So this one, what I'm going to do, I'm going to sketch the way we sketch rational function. Okay, so let's first find the vertical asymptote. So the vertical asymptote is x is equal to, to find the vertical asymptote, in case you have forgotten, you just get the denominator, equate it not equal to or equal to 0 to find the vertical asymptote. Or I can tell to say not equal to 0, but that is when you're finding the domain. So negative x will be equal to negative 2. So x will be equal to 2. So my vertical asymptote is at 2. Now I can find the intercept. Since on top I don't have x value, meaning I don't have x intercept, but I have got y intercept. To find the y intercept, what I'm going to do is equate where there is x equal to 0. So you end up having y 4 over 2, where there is x we put 0. So y is equal to 2, meaning 0, 2. So I don't have x intercept because on top there I don't have x. So if I sketch, I'm going to use two methods. Now the vertical asymptote is at 2. I'll put 2 there. I'll put a line. Okay, now one thing I want you to understand is this. As we are getting closer to 2, I want us to have two things. As we are getting closer to 2, what will be the value of y? Okay, but 0, 2, where can I find 0, 2? In y, 2, let me put 2 there, so it's going to be more like that point. So the horizontal asymptote, if I look at it, it's going to be 0. So it will be here. So it will be like that. Then we reflect it this side, it will be like that. So the issue is, as we are getting closer to 2 from the left side, when I say from the left side, I'm talking about this side. We are coming from here. As we are getting closer to 2, okay? As we are getting closer to 2. But before I use, okay, let me leave this graph for now. I'm going to come back and explain more. What I mean here, I'm going to do both sides. Limit as x approaches 2 from the left side and from the right side. Then we need to come up with a conclusion whether the limit exists or not. Okay? What I mean is this. Limit as x is approaching 2, let's start from the left side, 4 over 2. I'm going to plug in a number which is closer to 2 but from the left side. In this case, I'm going to get 2. I'm going to get 1. Okay? But if I want, I can get 1.99 is fine. Okay. I can get 1.99. That is okay. So if I get 1.99, I plug in 4. 1.99 is closer. So I'm going to get 4, 2 minus 1.9. 1.9 is closer to 2, but it's from the left. Okay? So what are we going to have is to be 4, then here it will be 0.1. Of which this one, when I do times 10, I'll end up having, I think, 40. If not mistaken. If I do times 4 or times 10, it's going to be, down part it will be 1. Yes, it will be 40. Now, what I have here, it should be the same as what I'm going to have when I start from limit as x approaches 2 from the right side. So from the right side, meaning I'm going to get 2.1. Okay? So if I'm also going to get 40, then I'm going to conclude that the limit exists. But I want you to understand something. So if I've got 4, here I'm going to have 2 minus 2.1. So what is 2 minus 2.1? I'll end up having limit. So now here I'm not, let me just plug in the values. Before you plug in the values, you need first to rewrite this. Then now I want to plug in the values. That's when I'll say 2 minus 2.1. 2.1 is from the right, meaning I've gotten this one from here now. So it represents that graph. Okay. I want to show you manually and also graphically, whereby you'll be able to know the answer using the graph, whether the limit exists or not. So it will be 4 minus 2 minus that one, I will end up having 0.1. So it will be the same, but I'm going to get negative 40. Now, here I'm getting negative 40, here I'm getting positive 40. Meaning, limit as x is approaching 2 from the left side of f of x is not equal to limit as x is approaching 2 from the right side of f of x. Therefore, the limit does not exist. The limit can only exist if, when I get from the left and from the right side, I should get the same answer. You see, when solving it look complicated, but again, if you know how to sketch it, let me now go back to the graph. The way this graph is going this direction. We can clearly see it's going toward to positive infinity. But this one, as you are approaching x from the right side, as you are approaching 2 from the right side, you can clearly see that it is going down, which is toward negative side. So the limit does not exist, because the other one, as you are approaching 2, it is going to the negative. The other one, as you are approaching from 2 from the left side, it is going to the positive side. Therefore, the limit does not exist. The limit can only exist if maybe this guy was coming from here also going that side. Even this one coming from there also going that side. Then we can conclude that the limit exists. So in this case, the limit does not exist, because the limit as x approaches 2 from the left side and from the right side, they are not the same. Okay. That is h. Now let's go ahead and also do I. So I, we're talking about limit as x. Now here, let me tell you this. When we're talking about limit as x is approaching infinity, if you know rational function is going to be easy. If you know how to find the horizontal asymptote, because here I can assure you that the horizontal asymptote is 0. The answer I should find when x is approaching infinity, I should also find 0. Then I'm good to go. So let's go. Now what I'm going to do here is I'm going to factor out x on numerator and on the denominator as simple as that. So it is limit as x is approaching 0 infinity, sorry. So I have, if I factor out x on top, I'll end up having 3 over x. So that this 3 over x times x, I'll end up having my 3. Down here, I'll also factor out x. Here, I'll remain with 1, 7 over x, like that. When you reach at this point, you can cancel these. So, you will remain with limit x approaching infinity of 3 over x divided by 1 plus 7 over x. When you reach at this point, you can just plug in now 3 over infinity divided by 1 plus 7 over infinity. Now, anything divided by infinity is 0. That's what we said here. Anything divided by infinity is 0. So, what I'm going to have here is 3 over infinity is 0. So, on top there I have 0 over 1 plus 0, which is 0 over 1, which is 0. Like I said, it's the same as finding the horizontal asymptote. So that is it for question 1.
So this is a piecewise function. Now if you look at the questions that we were given, the first one says, is the function continuous at x is equal to -1? Is it continuous at x is equal to 1? What values of x is the function continuous? What value should be assigned to a function to make the extended function continuous at x is equal to 2? So at the end of this question, you understand what it means for a function to be continuous. So to just help you understand and analyze whatever we are talking about, I'll sketch the function that we've been given. Alright, so let's come up with the xy plane just there. Now let's try to analyze the domain that we have and break it down. So we have from -1 to 0. So let's come up with -1. You can put -1 there, and then we can have a 0 there, and then we are going all the way up to 3, right? 3 is the maximum number, so you can say 1, 2, 3. Since that, if you can make it a bit bigger, extend a bit, 1, 2, and 3. That's good. Okay, so that's what we have. Now we can try to sketch. So for the first one, the function we have is a quadratic function moving from -1 to 0. Okay, so you can come up with a table of values first. So f of x and then value of x. Alright, so we have -1, 0, 1, 2, 3. This is just a rough one, very first one. Okay, so for -1, the function that applies is this quadratic function. So instead of calling it a quadratic function, I'll call it a quadratic equation because the function is only 1. Okay, so -1 is included because of less than or equal to x part. So if you put -1 in that equation, -1 squared is 1 minus 1 to give us a 0. So that tells us that we are starting at that point, -1, 0. And then of course, you can, out of curiosity, you can try the number between -1 and 0, which is of course -half. -half squared is +1 over 4 minus a 1. So I believe that is going to give us -3 over 4. -3 over 4. So if we say our n is somewhere here, then we expect it to be somewhere 3/4 below. So you can say almost there. And then of course, if you put a 0 there, just to estimate where it's going to end, of course 0 is not supposed to be included. So if you put a 0 there, it will give you -1. So at -1 it is not necessarily continuous, so just say the function is moving like this. Okay, it's moving like that. So at this point it is not continuous. So what is at t? Take note, this is at t -1. Okay, and then we can continue. Then the other part is also starting from 0, but 0 is also not included, so we can just put it there. We can just estimate for the sake of, so if you try to put a 0 in the 2x, it will give us a 0. So it's like that one is at 0, 0, but it's also not continuous. Okay, that's very important to understand. So I'll use brew for that. So something like that, and then that one is a straight line, so it's 2x. So we can also try to put a 1. If you put a 1 there, it's going to give us a 2. Right? So 1 will give us a 2. So let's say this is 1, and then that is 2. So we're getting a 2. Now, it is not continuous because 1 is also not included, unless there's a dash down there indicating equal to. So, and that is a straight line. So it's going to be like that. And then from there, the next part is x is equal to 1. This is as x is equal to 1. So that is a function. In fact, that is y is equal to 1. So we just have like a dot. So it's existing at this point. So that one is existent. So shade inside. And then we are starting again from 1, but 1 is not part. So this is a linear equation. So if you plug in a 1, y is -2, to be -2 plus 4, giving us a 2, right? So 2. So 1, 2. So it's also starting from that point, but also not continuous. And then it's also a straight line. So you can try the next point, which is 2. If we put a 2 there, to be -4 plus 4, giving us a 0. So it's moving like this. It's a straight line. Now, is it existent at 2? If we check at 2 again, we are seeing that at 2, 2 is not part of. So we'll just draw a circle there to just indicate that it's not continuous at that point. Okay, so not continuous. And then from there, again, the last function as well is not continuous. 2 is not part of it. And then it's moving, it's f is equal to 0. So the y is equal to 0 is the x-axis itself. So it's moving all the way up to 3. But 3 as well is not part. So even at 3 as well, we need to be very careful and show that it's not continuous. Like that. Knowing that is 3. And then for the sake of just showing, I can use a different color along the x-axis to show that the function continued like that. Okay. So we finally now sketch the entire function on the graph. And then I can remove this so that we have enough space to answer. And then remove all those things that we are helping us. Okay, there we are. So can also make this one a bit clearer. So here what we had is we had -1, and then we had -1 there as well. And then of course here it's a quadratic, so it moved a bit like, started from there and then moved like that. At this point it's not continuous, very important. Okay, because at 0 it is not part. Okay, so I think we have it on our graph now. So we can now try to answer bit by bit. So the first one says, is f continuous at -1? So what does it mean for a function to be continuous? So for a function to be continuous, it means, before I talk about the formal definitions under calculus, for a function to be continuous, it means the function exists at that point and then the limit also exists. So when the function at a given point, let's say at the point C, f of C, when it is equal to the limit of the function as x approaches C, when the limit at that point and the value of a function are equal, a function is said to be continuous. Okay, so what does that mean? So in this case, if you try to assess that point, you can see that I've shaded inside, which indicates that the function is what? The function is existing at that point. So we can say f of -1 is equal to what? If you substitute in that equation, even from the graph you can tell that it's what? It's equal to a 0. Now what is the limit as x approaches -1 for that function? For a function, it's also equal to what? -1. Because if you come from the left, of course from the left you don't have anything, but since you're coming from the left, it will just be at that point itself. It's already existing. Then coming from the right, using this curve, we are reaching -1. So are we reaching -1? Sorry, we are reaching 0. I mean to say we are reaching 0 because we are putting the y value. So since these are equal, we can confidently answer the first one to say the function is continuous. Yes, because f of -1 is equal to the limit as x approaches -1. They are all equal to 0. So we've answered the first one. We can go to the next one. Is the function continuous at x is equal to 1? So why is x is equal to 1? There we are. So what is the function at that point? F of 1 is what? So it's existing at that point. It's also equal to 1. Now what is the limit? So the limit as x approaches 1, so we start from the negative side. From the negative side, we observe where the function is. So this is the negative part of 1. So as we approach 1, the function is reaching that point. It's going towards what? It's going towards 2. So what is the limit from the negative side? From the positive side, which is this one, before 1, after 1, so it's also coming towards the same point as it reaches 1. So it's also equal to that. So which is also equal to the limit as x approaches 1 from the positive side. So since that is the case, we can clearly say that the entire limit itself, the limit becomes x as x approaches 1 is thus equal to 2. So now if you check the 2, are they the same? No, they are not. So the function is clearly not continuous because the limit is not equal to the function at that given point. So this one is a no. Now at what values of x is the function continuous? So we can clearly indicate the points where it is discontinuous. So we'll just come up with a set to describe that anyway. So we can clearly see that point. At that point, if the function is continuous, so since -1, since it is part, we'll say from -1, I'll use that bracket under set theory, all the way up to, that is 0. Now 0 is not, at 0 it is not continuous, as we can see, because we've not shaded inside, so it's not. So we'll combine that with, again, the function is continuous again from between 0 all the way up to 1, but at 1 itself it is not continuous, as we saw. And then union, again between these 2 points, again that is from 1 to 2, function is continuous, but they are both not part. And then again it is continuous between 2 and 3, again 2 and 3 are not part, so that's why I'm using the curved bracket. So we can see that from the domain, only -1 itself is part, and also the points where we are seeing the line continuously. That is the point. Those are the points where the function is said to be continuous. Okay, so I believe you understand what that means now. So take note of that. We are now on the second from the last question, which is D. Um, what values should be assigned to f of 2 to make the extended function continuous at x is equal to 2? So why is x is equal to 2? So x is equal to 2 is this part. Okay, so x is equal to 2. So what can we say about x is equal to 2? The function f of 2 itself is equal to what? F of 2 does not exist. As you can see from the graph, f of 2 does not exist. Okay, does not exist. Then what's the limit? So the limit as x approaches 2, from the left and the right hand side, they are all coming towards this very point, which is 0, right? So if we want the limit to be if we want the function to be continuous at that point, then the function or the f of 2 should also become equivalent to what? To the limit. So it should also become equal to the limit of the function as x approaches 2. Of course, I need to indicate f of x, which is equal to what? 0. So a function of a value of f2 at x is equal to 2 should also become what? Should become 0, so that it is equal to the limit. Then the function is going to become continuous at that point as well, because as it stands, the limit is equal to 0, but the function itself does not exist because it is not defined. So the function become continuous thereafter. And then finally the last one says, to what new value should f1 be changed to remove the discontinuity? To what value should f of 1 be changed to remove the discontinuity? What does that mean? What does that mean? So if you look at f1, you can clearly see that the function itself at f1 is 1. Okay, the limit we saw clearly. In fact, this is what I indicated here. The limit as x approaches 1 from both the positive and negative side is equal to a 2. As we can see, they are all approaching 2 from the left and the right. Okay, as x approaches 1, it's equal to 2. Now, to what new value should f of 1 be changed to remove the discontinuity? So we are changing the value of a function. So we can only change the value of a function. For it to be continuous, they're supposed to be equal to the limit. So just like we saw previously from the previous question, we'll do the same here. So a function value would have to go to that point, then the function will become continuous at that point, or the discontinuity will be removed. So f of 1 is supposed to be equal to 2 as well, if we are to remove the discontinuity at that point. Okay, so this is where we end with question 1. So you can actually access all these questions as you register on our site. So use the link in the description to have access to all the solutions under calculus, and also the next tutorial sheet, which talks about differentiation in detail and integration. Thanks very much for watching.
So let us go ahead and also look at question 3, which is also part of the continuity of the function, which is in conjunction with question 2. Okay, so the first question is saying define f of 3 in a way that makes f of x is equal to x squared minus x minus 6 over x minus 3 to be continuous at x is equal to 3. Now, here's the issue, guys. If we are to plug in 3 direct here, and the result will be 0 over 0, this is undefined. Now, they are saying we should define this, we should make it defined such that it should make this function to be continuous at x is equal to 3. What do we do? So what I'm going to do is, we're still talking about limits. This is just a continuity of the limit. So you say limit as x is approaching 3 of x to the power 3 minus x minus 6 divided by x minus 3. So like I said, if I plug in direct 3, I'll end up having 0 over 0, which I don't want. So I need to find a way on how I'm going to, I can only make, this can only be defined if x is not equal to 3. But they are saying that we need to make it defined when x is equal to 3. So let's see. So there we go. We need to just simplify or factorize the numerator, which is this is x to the power 2. X to the power 2 minus x plus minus 6. The product is negative 6. The sum negative 1. Factors, I believe, is negative 3 and plus 2. So that yes, meaning I have now x minus 3 and x plus 2. So I'll replace this with the numerator. I'll keep on bringing limit as x approaches 3 of x minus 3, then x plus 2. I divide this by x minus 3. Now I can clearly see that these two can go. Now the function, I believe, is going to be defined. So I've got x plus 2. When you reach at this point, since you want to plug in the value and it's going to be defined, you stop introducing limits. So it's 3 plus 2, which is 5. Now, how do you present your answer? So here, this is what we're going to do. For this function to be defined, you say f of x will be equal to, you write first the first thing which you have been given, which is x squared minus x minus 6 divided by x minus 3. For this function to be defined, x should not be equal to 3. Then it's going to be defined. X should not be equal to 3 is going to be defined. Another condition, we have found that it should be 5 when x is equal to 3. When x is equal to 3, the y value should be 5. So that's the answer. Okay, it's just a simple thing. You have your thing, put it there, then you know that that value you have been given, just put not equal to. Okay, as simple as that. Then the next one you're going to do, the answer you have found, then the condition is that x should be equal to that value you are plugging in. So I believe you can do B. Let's try B. So B is basically the same thing. So in that case, the product is, if I plug in 2, it will be 0 over 0. So the product is negative, negative 10. The sum is positive 3. Factors, negative, is it going to be negative? Plus 5 and negative 2. Meaning I'll have x plus 5 and x minus 2. So let's go ahead and continue now. So it will be limit as x is approaching 2. Where there is the numerator here, I'll replace it with what I have found. I divide this by x minus 2. Now these will cancel out. I'll remain with limit as x approaches 2 of x plus 5. Now I'll say equal to 2 plus 5 is equal to 7. How do you present your answer? Same way. I'll say for the function to be defined, the first guy divided by x minus 2, the condition that x should not be equal to 2. The next one is 7, the condition that x should be equal to 2. As simple as that. As simple as that. Let's try to go for part C. It's basically the same thing, the same principle I gave you under introduction to limits question 1, where I said limits as x is approaching, if you have that one can be written as x, the top part only can be written as x to the power 3 minus 1 to the power 3. which is going to be, I said if you have got a to the power 3 minus b to the power 3, it can be written as a minus b, a plus ab plus b. So in that case, my a is x minus 1, my b is, or my a again x, then plus 1 times x is again x, then again there I'll have 1, so it's more like I've got 2x. Okay, so that is the same as x minus 1, then 2x plus 1, like that. I'll replace with the numerator, the top, yes, the numerator. Then the denominator is the difference of 2 square, so that is x plus c, x minus 1 and x plus 1. So I'll go ahead and say limit as x approaches that number, which is 1, of that x is going to be replaced with x minus 1, then x plus c, or 2x plus 1 divided by x minus 1 and x plus 1, like that. Now we can see that these two guys can go. Now it's no longer going, it's not going to be 0 over 0, so it will be 2x plus 1 x plus 1 equal to, now you can plug in the value 1 plus 1, so it will be 3 over 2. Yes. So how do you present your answer? Like I said, it's going to be the same thing. F of x should be equal to, for it to be defined, you just get the original function x squared minus 1, the condition that x should not be equal to 1 for this one to be defined. Again, for it to be defined, 3 over 2 for x should be equal to 1. Done. Let's go to D. So D, we basically have the same things. So I'll start with the top part. The product for the top part is negative 8. The sum for the top part is 2. Meaning the factors are negative 4 and positive 2. This time that's negative 8, that yes. And I'll end up having x minus 4 for the top part, x plus 2 for the top part. Let's talk about the denominator. The denominator, the product is negative 4. The sum is negative 3. What are the factors? The factors are negative 4 and positive 1. So that negative 4 times positive 1 is negative 4. Negative 4 plus 1, negative 3. Then I'll end up having x minus 4 on the denominator and x plus 1. So I'll say limit as x is approaching that number 4. On the top part will replace with x minus 4, like we have said. Then the denominator will replace with x minus 4 and x plus 1. We can clearly see that these two guys can go. So limit as x is approaching 4, I'll have x plus 2 divided by x plus 1. I want to plug in the value, I'll say equal to 4 plus 2, then 4 plus 1, which is going to be 6 over 5. How do you present your answer? It's basically the same thing. I'll say f of x, for it to be defined, the first one divided by x squared minus 3x minus 4, the condition that x should not be equal to 4, then it's going to be defined. Then for 6 over 5, the condition that x should be equal to 4. As simple as that. I believe this is just simple, guys. Okay, that is it for question 3. So let us go ahead and solve question 6, which is saying use the chain rule to differentiate each of the following. So chain rule, when I talk about chain rule, what we need to understand, guys, is that if you have got f of x to be equal to u raised to the power n, then the derivative, which is f of prime of x, you drop the power, the u remains the same, the power reduces by 1 times the derivative of u. So for example, the first question which I have, I want to find dy dx. Then I'm going to say the first one I'm going to use, I'll say let u be equal to 3x minus 2. Then my u prime will be equal to 3. Then what is my n? My n is 8. What of n minus 1? N minus 1 is 8 minus 1, which is 7. Then I can go ahead and plug in the value. So it will be dy over dx. We're solving part A is equal to my n is 8, open brackets. My u is 3x minus 2. Then my n minus 1 is 7 times u prime, which is 3. Then I can say 3 times 7, which is 3 times 4. 3 times 8 is 24. I keep this constant. That's the derivative of that guy using chain rule. Okay. Now let us go ahead and solve. Before we go for the lean, and I'm going first to solve d. Okay, so d I can write it to say it's the same as I remove the square root. It will be 4x minus 3 raised to the power half. So my u, okay, like we said, my u is 4x minus 3. Then my u prime is just 4. Then my n is now half. Then n minus 1 is so you do 1 over 2 minus 1, which is negative half. Okay, so using that formula which we said, f of x prime is equal to n minus 1 times u prime. Using that formula, I can clearly see that my dy over dx will be equal to my n is 4, my n is half. Then I keep this constant raised to the power negative half times 4. So then it will be half times 4, which is 4 over 2, which is 2. So it will be 2 open brackets 4x minus 3 raised to the power negative half. Now if I want to remove negative on top, meaning this 2 has to go on top, then this is going to be on the denominator and it's going to be to the power half, not negative. So it will be 2 divided by 4x minus 3 raised to the power half. Now the negative has gone because this 2 has gone on top. Then another thing which you have to take note there is when I raise anything to the power half, it's the same as the square root. So it's the same as that. That's the answer. Okay. Then now we can go ahead and do part B. So part B, we are talking about trig now. Okay, we are talking about trig. So let's first talk about the basic idea behind. We start with cos, the derivative of trig. So the derivative of sine x is cos x. The derivative of cos x is negative sine x. Now let's go to tan. What is the derivative of tan x? The derivative of tan x is equal to sec squared x. You can prove this by saying sine over cos, then you use the quotient rule. Now let's go to cot. Let's go to cot. What is the derivative of cot? So the derivative of cot x is equal to negative cosec. Okay, negative cosec x. So these ones you need to know them. Now I'll start with the part B. So like we said, dy over dx is going to be um, you drop the power, keep this constant, then the power reduces by 1, so it's going to be 6 minus 5. So using the same formula I gave you, it's going to be 5 times the derivative of what is inside. What is the derivative of sine? Is cos x. What's the derivative of this? Is cot, sorry. The derivative of cot I've given you, so it's going to be minus cos x, cos squared x, cosec x. Then if I want, I can leave it there to say that's my answer. I end there. Then another thing is I go to part C, where I have, let me now teach you the basic idea behind differentiating log. If I've got ln u, the derivative is going to be u prime divided by u. So if I have got ln x, the derivative of u in that case is x, so it's 1 over x. Okay, so for example, there we have y is equal to ln sine squared x, like that. So meaning dy over dx, I differentiate that. Now, how do we differentiate sine squared x? Sine squared x is basically the same as sine x then raised to the power 2. So you drop the power is 2, you keep this constant, times the derivative of what is inside. This is going to be reduced by 2, which is going to be just 1. So the derivative of that is cos x. So it is 2 sine x cos x, meaning that is the derivative of what is inside there. So now I'm going to say, since that is now my u prime, sorry, so my u is just the sine squared x, so I'll put there u prime is 2 sine x cos x. I divide it by u, which is the original u, which is just sine squared x. So then I'll see that dy over dx will be equal to 1 sine will go and that sine will go. So down I've got 1 sine, so I've got 2 cos x divided by sine x. So what is cos x divided by sine x? Is cot. Okay, sine over cos is tan, so this is going to be 2 cot x. That's the answer. Okay, now let us go and solve part E, because D I've already solved. Now here I discover that when I leave some questions, you guys don't answer, so I'll be solving everything. I'm not shaken. I'll solve everything for you. So we go ahead and solve E. It's basically the same thing. Now let us talk about this. How do we tend to differentiate? Let's say we have got sine 2x. So the way we differentiate, since the angle here has got some numbers or a number, then I'm going to say it is cos, this one remains the same, times the derivative of this guy, which is the angle. So what's the derivative of that guy? Is 2. Then it's now 2 cos 2x. So it's basically the same as what we have here. Y is equal to this. So meaning dy over dx, I'll just differentiate this. What's the derivative of sine? Is cos. Leave this in the way it is inside. This is the angle. Okay, leave it the way it is. Then times the derivative of the angle. So what is the derivative of 3x squared? It is 6. I'll put them in bracket. 6x. The derivative of 2x is just 2. The derivative of 1 is 0. So this becomes my final answer. Okay, these are basics, guys. Now it's basically the same principle. Sine 4x is basically the same as sine x raised to the power 4, like that. So use chain rule. You drop the power, so the power is 4. Then you keep this constant. The power reduced by 1, so it's going to be 3 times the derivative of what is inside is going to be cos. Meaning 4 times cos, you end up having 4 cos x, open brackets, sine x raised to the power 3, of which this can be we are saying that if this is the same as this, then I can drop 3 to be there, so it's going to be 4 cos x sine squared x, or sine to the power 3 x. That becomes my final answer. Okay, then I'll go to part G. Part G is the same. I'm going to say I'll leave this, I'll remove the square root, meaning it's raised to the power half. The property of logs, when you are differentiating this dy over dx, you drop the power, you keep this constant, okay, then the power reduces by 1 over 2 minus 1 is negative half, times the derivative of what is inside. What is inside is this. What is the derivative? We said you differentiate this, so it's going to be 2 over the original. So the derivative there now, it is 2 over the original is 2x plus 1. Now if I do half times this, the 2 and 2 will go, and I will end up having 1 over 2x plus 1. Then I've got ln 2x plus 1 to the power negative half. Now if I want to remove the negative, this one will go on top, this one will come down with the ln 2x plus 1. So it will be 1 divided by 2x plus 1, like that, then ln 2x plus 1 raised to the power now half, of which negative has now gone. So now, since half is also the square root, the final answer will be 1 divided by 2x plus 1, like that, then the square root of natural log of 2x plus 1. That one is my final answer. There is no debate about this one. Or in case you have not seen the answer, that's the answer. That one. So h, we now go to h, which is, we'll do the same. So in that case, remember our formula, guys. F of x is equal to u and f prime of x, you drop the power, keep this constant, this reduces by 1 times that. Now in that case, what is my u? My u is cos x plus sine squared x. My u prime, if I differentiate this one, is going to be negative sine x, but the derivative of sine squared x is the same as we said, it's the same as this, of which is going to be 2. You keep this constant, then you differentiate. Now that one is going to be cos, so it's like you have got 2 sine x cos x, so plus 2 sine x cos x, like that. So I'll do the same now. I'll say dy over the x will be equal to, you drop the power 7, keep this constant u, which is just cos x plus sine squared x raised to the power, now the power reduces by 1 6, time the derivative of that one is negative sine x plus 2 sine x cos x, of which, if you want, you can end there, or you can say this is the same as, you can start writing this one, then minus should be in between, so it will be 7 open brackets 2 sine Sin x cos x, then minus sin x, then cos x plus sin squared raised to the power 6. That's my final answer. So the first time I gave you what is the derivative of tan. So now this one I'm going to rewrite it is the same as tan squared x raised to the power half, meaning my dy over dx, you drop the power, keep this constant, then the power reduced by 1 is going to be half, negative half, times the derivative of now we are trying to differentiate this, so it's the same thing as that one we talked about. So now what is the derivative of tan? I gave you guys, and I said the derivative of tan is sec squared. So the first thing here, you drop the power, okay, this remains constant, then the power now reduced by 1 times the derivative of what is inside, it is sec squared x. So it's like you have got 2 tan x sec squared x. So it's the one you are going to do times there. So you have 2 tan x sec squared x, meaning these 2.5 will cancel. Then we have remained with dy over dx will be equal to, there is just 1, so meaning I have got tan x squared raised to the power negative half times tan x sec x, sec squared x. So now the one which is here, you can shift it to be on top, this one comes down, or it's the same as shifting this to be on top, so it's going to be tan x sec x squared divided by, because this has got to the power negative, meaning it is on the denominator, okay, so tan squared x raised to the power half, negative has gone. Now you know that we can still modify it and say that is the same as the square root of tan squared x, and that becomes my final answer. That is it for question 6.